Here I'm going to demonstrate BDR FHIR, which gives the users and you a simple mechanism to find the data that you seek. BDR gives users the ability to add aliases to FHIR's column names with all the EHR, EMR HL7 names to FHIR's unique 37,340 column names, which they standardized. So BDR FHIR has added the capability for aliases to a cross-reference table for mouse over display when searching for information. So here I'm going to go ask to do a FHIR report, and we're going to pick R4, we can do R5, we can do R3, and here I'm going to go for first the patient resource, and here we're going to do a search for a couple columns, but not by the names that are used within FHIR, but which are used in other systems that you might be used to. Say you're used to the word town. Well, town is now address and city. Say you're used to first for first name. So if we key in first, we see first name is now given name. If we look for last name, it's now name family. Now if we want to just go to the straight FHIR naming convention, then we can go look for other things that we're used to also, and say address, and say we want address country added to it, and then say we wanted to go into another resource, so we can go into the observation resource, and let's say we're just looking for some code information. We can come in here and key in the word code and see that we want code coding display, and now we're going to run this process, and while the report's running, I'll show you from prior reports. You can see what information you went after, what the FHIR name was, and what the name was that you searched for, so you'll know that's your value. This process will take the frustration out of people that are used to multiple EHR, EMR, HL7, and other healthcare systems. That's going to take a while to get accustomed to the new national naming and the conventions and naming that FHIR uses. So till you're fully used to that, or even when you are, you can still go in and search by the names you're used to, because the interface allows you as the user, so while the job is running, we'll go into the administrator process and look at FHIR configurations. As we see in the FHIR resources, as we go into FHIR resources and we look at the R4 version, when we come in and we are searching and looking for different fields, like I used town, and town is really address city. The reason it finds that is we allow the user to come in and under a description field, comma delimited, put location, town. It's collaborative, so however many fields people want to put in, they can put in. So you notice I found that with town, so that just simplifies the user's job in finding the FHIR representation of what you're working with. Now with the job completed, we can click over here to click to view, and we can see the columns that we requested, and we can open up the report, and in the report we can bubble over and see that patient address city, maybe we're not used to that, that's location in town. Patient name given is first name. Patient name family is last name. And if there is no user entered equivalent to a name or conversion, it'll just show none. Now the next thing that we can do is we can report this to a database, or we can download it. So if we were to report this to a database, so you want to do a migration to a big data database in S3 or Redshift, a Snowflake, and HDFS, you can do it. In this case, we're just going to go back to MySQL. We'll call this demo 10 underscore 1 for today. We'll test our connection. We'll hit the next button and the run button. And while this is running, we can go into MySQL, look at the migrate tables. We don't see the demo 10.1 table here yet. We can refresh to see if I got the point to create the schema. Once it creates the schema, it will populate the data, and what's nice is it will populate the data in an encrypted format, which then I'll show you. As long as you have authority, you can decrypt it, or even as we store other data encrypted, as you see here. FHIR URLs and APIs will run as usual based on authority. So here we have demo 10.01, which is a new table, and as you can see, it's encrypted. So we securely end-to-end did our processing, and we wrote the file over, and it's an encrypted state. But if we have the authority, we can click the open button, we can click run the process, and the process will run. In this run, and especially because you migrated this, you have ownership of it, but you also have responsibility of that file. Now when we come back, when the process is done and we refresh, it still might be running, but we'll see. And let's right click and select the top 1,000 rows, and now we see that the data is decrypted. And once again, if we wanted to, and we should, if we're done working with the data, it's in decrypted format, we would once again want to encrypt that data. Now, when we go look at the display for the report, and before we opened it and we did a migrate to a database. Now, if I am a patient, as of July 1st, I have a right to see my data and work with it. We generate an encrypted key for security using HTTPS, SSL, SSH, and Crypto.js and other security methods without an application, and we could bring this data down to an iPhone, an iPad, most any mobile device or computer. So when I'm done with the process, it's going to start and build a download file and all the security mechanisms. I'm going to save this file, and now I will go into files, I will go into downloads, I will look at the last file generated, I will open it in an Excel format, And here we see the data that was in the report, which we have a right to. We can share it with doctors. We can share it with anybody we want. We can just use it for our viewing. Now, since we're still have the data encrypted, which it should be, so let's go into the FHIR repository and let's look at a couple major tables. First, let's look at the string table. And in the string table, which I have open here, we can see, and let me just refresh the data. Here we see that the data, select all, so if we execute that, we can see that the data is encrypted. We'll go to what's called the version table where the blob fields are stored, and we can pick on any one of the blobs, and if we open that up in editor, we can see that that data is encrypted. Now we're going to go into Postman, and what we're going to be able to do is go into the FHIR data, port 8080, FHIR, patient 1. We're going to hit the send, and you notice that because we're using the FHIR and Hibernate interceptors and our APIs in microservices, we're decrypting the data, making it viewable and available to those that have authority to look at that. If I click on history here, I will see other processes that I ran, and we will look at not just one patient, but we're going to want to look at all the data within that patient. And again, in the bundle and in the JSON format, we can see all the data, all the resources, and everything is in a decrypted format. So what I hope this is showing is that the data at rest will always maintain its integrity of being encrypted from end to end. The blobs that store the majority of the data that's used stays encrypted. Fields that are in the string file that are used with cross-reference files to put together the records for patients is all encrypted. It gets decrypted as needed throughout the processes, but with the interceptors and our APIs and microservices, the data is easy to work with. This is true end-to-end encryption. Our ingestion process encrypts the data, and the data is encrypted and secured all the way down to the iPhone or all the way into its migration into any RDBMS or big data repository that your data scientists and analysts are using. I hope this is helpful to show how we have filled the gaps of areas that weren't and don't meet HIPAA compliancy, CCPA, GDPR, and other compliancies within FHIR, and helps the users protect protected health information and PII for CCPA and GDPR. All the protected data will be AES 256 encrypted. So when you are breached, not if you are breached, your data is secure. And if you back up based on your latency a couple times a day, you can restore it to another cloud, on-prem instance, and be back up and running very quickly and not be threatened by or harmed by a data breach or a ransomware attack. I hope this has been helpful and just shows how much value and how much can be done outside but integrated into FHIR, and how the capability of utilizing like names make the processing within FHIR much easier for people to be able to search and see the data names and metadata that they are used to, so they're not spending 80% of their time, just like data scientists were, in finding data. Now users won't be spending 80% of their time finding the data. They'll find the data very quickly, know where it is, know what its values are, and be able to work with it. I thank you for taking the time to see this video. We have a complete video library in YouTube, so if you're looking at this one, you can just go to the whole library and probably see 100 or so videos. We do high-speed data migrations, such as to Snowflake from Oracle as an example, at nearly 2 million rows a second. We do everything dealing with CCPA, GDPR, HIPAA, FHIR, consent. There's just a real lot of areas in data governance, data profiling, outlier discoveries, completeness. This is a really end-to-end technology, and most important, no matter what state you're in, what country you're in, you have a fiduciary legal responsibility from the board of directors to C-levels on down to protect customers' personally identifiable information and protected health information, and we feel we are adding that value for you. Thank you, be COVID safe, and I'll see you on our next video.